Hello, this is Dr. David Kordowitz and welcome to Solidworks. Today we're going to be talking about building assemblies. Previously, we have discussed building parts using our base boss tools and our cut tools. These parts are single objects that exist of a single body, where assemblies take these parts and put them together into a whole product. Let's begin. The first part of building an assembly is building your parts. So for this project, we're going to be using a series of 3 parts. First, we have this pin. This is an adjusting pin. We'll sort of show you when it comes together what it does. The second one is our base, which is this sort of cubic rectangle prism type thing. And then the final one is our yoke. And our yoke looks like this. So what we're going to want to do is put this together into a single object. One important thing is that when you're building assemblies, it is much easier if you have the part files open while you're working, as opposed to just simply adding the part files later. When we build our assembly, any updates that we make to the parts in the process will automatically update in the assembly, so this allows us to do some interesting tricks. So the first thing we're going to do here is go File, New, and we're going to choose an assembly, unlike our previous choices. When we choose assembly, we're going to get a new type of part or a new type of object. And the first thing it's going to offer us is, what do we want to begin with? And I'm going to say we should probably begin with the base because everything else is going to be based on it. So we're going to choose the base and it should become live and we can drag our mouse around. I'm not even clicking. And then once we have a position we want to put it in, you click. And that places it there. Now, what I want you to notice real quick is if you go over to the design tree, if you notice in parentheses, there is an F. That F means that this object is fixed. Now, where the origin is completely arbitrary to the part. However, we know that this is fixed in space and this object can't move and everything moves around it. I tend to usually break this fix and use what we call a mate to position this correctly. So to release the fix, what we're going to do is right-click on the part, and then we're going to go to float. Now that we've changed over to float, we can notice that there's a little minus sign over here in the design tree. That minus sign means the same thing it does in a part. It means that we are underdefined. So now we're going to go over to the assembly tab and we're going to use a mate to redefine where this is. And in this mate, we're going to go ahead and choose the global origin from the flyout menu, and we're going to come down into the base and we're going to choose its origin. So we're going to mate the origin of our part to the global origin of our assembly. So in other words, this is 0, 0, 0. And if we look in the menu over here for mates, you can see that align axes is checked. This means that the X, Y, and Z of the part will be the same as the X, Y, and Z globally in our assembly. This is a good thing for certain types of questions, particularly center of mass, as long as you know that your orientations are correct. If you don't, I'll show you a trick in a little bit of how to handle it. So we click OK. Now note with mates you can use the enter key on your keyboard to approve them. And mates are very much like relations. So it would be kind of boring if you notice that minus sign went away, but it's kind of boring to have a static object that's just just basically a base. So let's go ahead and add our yoke. To do that, I'm going to come up to Insert Components in the upper left-hand corner, and I'm going to pick the yoke. Now, where I put the yoke in this diagram right now doesn't really matter. I can put it anywhere I want. Now we're going to use our mates to go ahead and set up where the position of this should be. So I'm going to click Mate. And now the first thing I notice is that this top up here, right here, should be on this top right here. So we're just going to click those two, and it will automatically choose the mate that it thinks is best for what you're doing. So in this case, it's saying it's a coincidence mate. We could switch it simply by clicking on the other mate types to parallel or perpendicular or to a distance or angle mate. So we hit enter now. One thing I want you to notice is it's cut in the middle of our part. We don't really want it that way, so let's go ahead and click the inside face here, and we're going to click the outside face here. Again, we want those to be coincident, and they are at this point. So we're going to say OK. Now, if you notice on our flyout tree, if we click OK on the mates, it'll clear out. We are still underdefined. So one way to tell how you're underdefined is just grab the part and pull on it. Well, it moves forwards and backwards. I can't move it side to side. I can't rotate it. I can't make any changes to it. So what we need to do now is mate how far away this part is. So let's go ahead and mate this front face to, say, the front face of this. Now, it says it wants coincident, but that's not really what we want. We want a distance mate. So we're going to click on distance, and now we can enter whatever dimension we want. So say we want it to be 30 out, 30 millimeters away. So you click that, and then we're going to say, OK, we like that. So now we're 30 millimeters away, and let's see if we are fully defined, and we are. In other words, now this part cannot move in any way. So that's actually a really useful thing to do. But if this were real life, this thing would be able to still slide. So what we can do is add our pin. So again, insert components, and we're going to choose our adjusting pin. I'm going to put this out here somewhere. Now, an important thing to notice is when we did the insert components, we have this browse button here. If I click the browse button, it brings up a file. It brings up a file explorer and allows us to find the file that we want to work with. So if it's not open, it can be added that way. If it is open, it shows up in the list here. Okay, so let's go ahead and mate, for example, this shaft. So we're going to go ahead and take this shaft. We're going to select mate, select the outer boundary here. And then I'm going to zoom in real close here and insert and click the inner boundary of this hole. And it will automatically choose a concentric mate. And concentric mate is the correct type of mate here, because a concentric mate basically means the two circles have the same center. So we're going to click OK. We're going to say OK. The next thing I want to do is go ahead and mount this line, so this horizontal line here, to be parallel with the axis, to be parallel with one of the planes. So if we go and hover over the planes, we can see that the front plane is probably the one we want it to be parallel to. I'm going to click the front plane, and I click this tube inside. And we are going to say that we want them to be parallel, and at this point it won't let us do that. So what we can do is we can go into our view menu here, visibility, and we can turn on our axes and our temporary axes, although it doesn't appear that we have any. Yes, we do. Okay, so this temporary axis right here is basically the line that runs along the center of that hole. So now we can mate that line. So we're going to choose that line in the center, and then we're going to choose our front plane. And then what that's going to do is align it to be parallel with the front plane, so our holes are across. So let's click OK. We can now come back into our view menu, and we can shut our axes off because we no longer need to be able to see them. So here we have an assembled part, and this is all together. This is an assembly, and we're still slightly underdefined because we don't know where this pin is. It can be up, it could be down, it could be anywhere. So what we're going to do is we're going to define, for example, the bottom of this to the flat part down here. And we could say that's something like, I don't know, 10 millimeters, for example. So we're going to say that, and we're going to click Enter to OK it, or click there. So now it is complete. Our assembly is complete. Everything should be fully defined, although it looks like a mate was broken. So to figure out what mate was broken, you kind of have to adjust a little bit and sort of feel it out. It's probably this mate here. We can always go back into our mates here, and we can always check and alter what the mate settings are just simply by clicking on the Edit Mate. So let's try this to 20. Another important thing to realize is you can flip your direction, which allows you to go in the distance in the opposite direction, so it would go through. And you can also flip your mate alignment. So if parts come in backwards, all you simply do is click on the two buttons that say made alignment, and that will alter it and reverse it. So now we'll take this and OK and rebuild. Okay, so now everything should be more or less complete. The last thing we need to do here is get our data from this assembly. So to do that, we can start with our mass components. So if we go to evaluate, we can go to our mass properties. And our mass properties tell us where the origin is, first of all, and the origin is right in the center here. So it doesn't look very aligned, but the y-axis is along the length. But let's say, for example, that we want to find it relative to a fixed axis. Now, on things like CSWA, this is actually a fairly common question to ask. They ask you what the center of mass is, which can be found in the middle of this page where I just highlighted, and they give you where the origin should be. So one thing you could do is you can attempt to mate the origin to that location. Sometimes that works well, sometimes that doesn't. So an alternate way to do this is using a reference coordinate system, and I'm going to show you how to do that right now. So if we click on reference geometry, we can choose coordinate system as one of our options. So let's say we want to go on the lower left-hand corner. So what we do is the first box up here is where is the origin of the axis. So we just click on that corner, and then we're on the x-axis. So what direction do we want our x-axis to be? Well, let's say I want it to be along this long length. I can just simply click there, and it will make that the x-axis. The y-axis is now the vertical axis, and the z is left to right, and I am okay with that. If I want to flip directions, I can simply use our flip button. So let's click OK. And now you'll notice that there's a coordinate system marked down here that says coordinate system. So now if I go into the mass properties again, I can, if I go into the mass properties again, I can look at this, and we have our center of mass in millimeters. Now notice it says report coordinates relative to default, which is our standard built-in center, our center. So if we go ahead and hit the default, if we pull this menu down, we now have coordinate system 1, which is what I just placed. If I click that, you'll notice the center of mass changes relative to that coordinate system. This would be your answer right here if they asked you what your center of mass was relative to that corner. So now a couple of other really quick and useful tools. So let's say we want to take a measurement off of this thing. Let's say we want to figure out how high it is from the top of the screw to the bottom. We can go to Sketch or Layout, and we can choose Smart Dimension. Now it's really important when you're doing this to go ahead and hit Reference Dimension before you click anything. So we can now click, say, the top of this thing, and we can go all the way to the bottom and click the bottom. And now I have a bracket that I pull out, and I find that it is 160 millimeters tall, and that will stay there just as a reference so we know what's going on. Now let's say, for example, I wanted to go ahead and change the size of the pinhead. That's actually not that hard to do. There's two different ways we can think about this. One is to come in here in the adjusting pin, and you can right click, and you can do edit part, which is up here. And what that'll do is open the part and allow us to edit it. Before we can do that, we need to save this assembly. So we're going to say pin lock assembly. So we need to save the assembly before we're allowed to edit the part. Right here, we're in the edit part location within the assembly. So you're fixing it within the assembly. I tend not to like to use this method because it complicates things a little more. If we have the part open, which we actually do, so we can come over here, yoke, base, and pin. Here we go. So we're going to open the pin up, and we notice that I have two extrudes. I've got the bigger extrude and the smaller extrude. Now I can come in here and edit the sketch behind it, and we're going to go normal to it. And all we're going to do here is, instead of this being 24, let's say this is now 50. And we click OK, and we exit the sketch. We now have a very different geometry to our pin, and if I save it, when we minimize this, it's going to ask, do we want to update the assembly? If we click yes, now when I open the assembly, you'll notice we have our new pin in place. So this allows us to go back and forth editing parts and assemblies together and allows us to modify things as we go. There are numerous types of mates available to you, including mechanical mates and advanced mates. Some of these are going to become more useful than others. So let's take a look at one of the more useful ones. We're going to go ahead and delete the mate, the position mate that positions where this is geometrically. So now this can slide again. So let's go ahead and do one of the more useful mates, and that's what we call a width mate. And what a width mate's going to allow us to do is it's going to allow us to define where things are going to be. So we can say, okay, the first thing we want to do is choose our width selection. So I'm going to choose the front of this thing and the back of this thing. So that's going to define our boundary conditions. So where can our piece fall within? Then I'm going to click the front of the yoke and the back of the yoke. And what it's going to do right now, based on how it's set, is it's going to find the center point where the front to the front and the back to the back are equidistant. Now we can pull down the constraint, we can change it to free, we can dimension it, or we can set it to %, we can do all sorts of things. But I'm going to leave it centered because that tends to be what we use the most. So we do that, and now we've changed our geometry a little bit. If we go back to our mass properties, what we'll notice is our center of mass will have changed. And that's because the location of the center of mass moves as we change the geometry of our part. This is why it is so critical when you get assembly questions to make sure that you assemble everything correctly, because otherwise the center of mass will be off and it will be obvious that you haven't correctly assembled things. So this is really the basics of assemblies, and the rest really is just practicing and doing more assemblies. So hopefully this skill will become useful to you and you will understand better how to use it in building devices. I'd like to thank you for your time today and see you next time.